welcome back my friends. On last week's video I showed you how to create a custom legend like this, and we even went one step further and built a custom legend like this where we moved the rectangle a little bit and put the text labels in between them. But one comment pointed out that there is a problem with how we built this. We have hard-coded a lot of things and this makes the legend not that versatile to use. Let's recap what we did and then I'll show you how to automate our build process so that we can use this type of legend on all of our plots. So here's the code for our first legend. Pretty straightforward, except that we used guide color steps. In case you haven't seen the first video, there should be a link popping up right about now. Now for our second legend we have drawn all the things manually. First we used an annotate layer to add rectangles, then we used the text annotate layer to add the text labels, and then we also added the body weight label for this chart by hand. And the crucial flaw here is that to create these labels we have basically hard-coded everything. So let's see what can go wrong with that. Imagine that I want to change my initial plot up here and use, say, bill length millimeters for the colors instead of the body weight. Then of course I have to change the label in my labs function, but the initial legend works just fine again. But in our hand-drawn legend, oh boy, things are messed up. Let's have a look. The colors of the rectangles still look alright, but the labels are way off because they didn't change. So what we need to figure out is how to set these labels in a way that they are dependent on the initial plot that we build our legend on top of. This would help to automate building such a legend, for example in a Shiny app. Also, if you were to put in a different number of breaks, say 7, then the amount of rectangles that you need to draw should change. In our first plot this works fine and the amount of colors that we see in our legend are different, but in our custom legends it's still the same. That's not great at all. Let's fix this. As a side note, let me point out that this number of breaks doesn't always exactly correspond to what ggplot does in the end. For example, if I put 6 here, this looks like this, and if I put 5 here, it looks exactly the same. I think this has something to do with ggplot trying to make nice break labels, but this doesn't really concern us. I just don't want you to get confused when you play around with this yourself and wonder what the heck is going on. And another small side note before we start, what the heck is body depth? No one has a clue what that's supposed to mean. Let's change that label to what it actually needs to say, to build depth. Totally my bad. Now enough comments, let's make our custom legend react to the changes in the initial plot. And we do this without hard coding this time. You ready or what? In the end, all of this comes down to figuring out how to extract the data that is saved in the ggplot. And the way to do that is to follow this Stack Overflow answer. Shout out to Toynbrand for this cool trick. I've learned a lot from this solution, so thank you for that. First, we need to take our plot and then we build it. We need to use ggbuild for that. We cannot take our regular plot variable even though there is information stored in there. But the thing is, inside of this regular plot variable, stuff like scales are not trained on the data without ggplot build. Usually RStudio calls this function whenever you call a plot, so that is why you probably haven't seen this build function before. In any case, so this is why we need this build ggplot function. Let's save the output into a variable. What we can do with this new variable is to navigate through all of the stuff that is stored in it. So we've seen in the first layer that we can decide between plot and data. Let's have a look at the plot one. Now we can look at the scales because we want to find the associated information of our scale fill distiller layer, right? And then we notice that there is something called getScales, which sounds like a function that we can use to get the fill scale. Nice, this gives us the scale that corresponds to the fill aesthetic of our plot. So let's save this into a variable as well. With the scale, we can now do the same thing. That is, we toggle through the options via the $sign and get access to the getBreaks function. You can see that this gives us the breaks of the color legend that we have already seen in our previous plot, but it also includes a missing value. Again, we save this into a variable, but we stick to those values that are not NAs. Excellent, we have our break labels now. We could even use the scale function with its internal map function to get the colors that correspond to the breaks, but that's not particularly useful in our case because we only get 4 out of 5 colors that we need. So let's just do something else instead. Let's just save the amount of breaks that we could extract from our ggplot into a new variable. This will be useful to calculate all the other things later on. Now let us look at our code from before and see what we have here. We have specified the centers of the rectangles that we plot, and we have also hard-coded the width that we want to use. Of course, all of this should be dependent on the amount of breaks that we use in our plot. And the same thing applies for the amount of fill colors that we compute. So let us first make the width dependent on the amount of breaks that we have extracted here. We simply declare a new variable that will correspond to this width, and then we replace the width of the rectangles with this new variable. And then we can think about how to put the x coordinates into a new variable too. First up, notice that we have used a padding here. This is something we should put into a variable in case we want to change the padding later on. So we put this into another variable and replace the 0.75 with that variable. Now we are ready to put the x coordinates into a new variable. I'm a sucker for descriptive variable names, so let's call it center x rectangle. Just like in the previous code, we used the sequence function to find values between 190 and 210. But this time we do not hard code the width. Instead, we simply let R figure out how to place these numbers based on the amount of rectangles. And then we add the padding like before. The only real difference here is that I've decided to not move the first rectangle by the padding and only start with the second one. And here's another thing I have decided. Look at me deciding all the things. I've decided to make sure that the left edge of the first rectangle starts at x equal to 190. This I can enforce by shifting all the centers by half the rectangle width, and this way we get centers that do not start at 190 but a little bit after that. This will help us later on to place the text label for the legend. More on that soon. For now I can replace the x coordinates here, and I can also replace the amount of colors in the brew_appel function. Wow, we have made a lot of changes at this point, so let's check how all of this looks right now. And surprisingly, this looks pretty decent. But let's also check if this actually reacts to, say, 7 breaks. Our first legend would look like this. So we re-execute the code that extracts the break information, and then our code produces the results that we want. Nice. We could center this legend a little bit more by putting the legend not between 190 and 210 and making this dependent on the range of the x-axis, but let's leave this part as it is. You can tweak with this later on if you want. Next, we have to think about our text labels. Right now these are still the old labels and they make no sense at all. But before we do that, you know what's coming. Let me remind you to hit that like button if you find this video useful. Thank you for your support, and now back to the video. So the easiest way to create the labels is to use the associated breaks that you have extracted earlier. These are the labels and you can place them right in the middle between the centers of 2 adjacent rectangles. To do that, you need to calculate the center between these 2 rectangles by taking your centers and then adding the shifted centers on top of that. In case you're not familiar with the shift function, that's what it produces. And once you have these 2 vectors, then you add them together and divide everything by 2. That's some quick math right there and will give you the centers between the rectangles. So let's save this into a new variable that we can reuse in our annotate layer. But since we don't want to get warnings about this missing value that you see here, let us filter them out. Finally, we put in the associated labels that we've extracted from our ggplot. And if you re-execute this, you will get labels that are placed perfectly in the middle of those rectangles. Beautiful. Now the last thing that we need to fix is to stop hard coding the body weight label. But since we made sure that our first rectangle starts at x equal to 190, we can set the x coordinate of the label to that exact value. No need to tweak anything like in the last video. And the way to make the label dependent on our initial plot is to remove this hard coded part here. Instead, you can use your variable in which you save your initial plot and access the labels. This will give you all of the labels that are inside of this plot, and so you extract the one for the fill aesthetic. Hooray! We have made our cool legend fully data dependent. Now we don't have to worry about our labels getting messed up because we have changed the underlying variable or something like this. Let's demonstrate this by using, say, only 3 breaks and a different variable. So we can go up here and in our code we can use something else from the Parma Penguins dataset. Maybe we can use the flipper length length again. I know we have used it already, but that doesn't matter at all. It's just for demonstration's sake here. And then of course one of the things we still have to change by hand is the label. Don't forget to change the number of breaks to 3, and then the moment of truth, we re-execute the part that extracts the correct breaks, and then re-executing our ggplot code. Yeah, we get nice results. In this case we could probably make the padding a little bit smaller though, maybe even smaller than that. Or we can even make it into something negative, because this range here is quite large for the amount of rectangles that we have. So that was everything for today. Thank you for the great question. Keep the questions and the comments coming. And if you want to learn more about ggplot, check out this video next. In there I show you how to recreate a clean dot plot from the Pew Research Center with just ggplot. Or if you want to learn something else entirely, then maybe this video here is for you. I show you how you can do a lot of similar calculations in one single swoop, instead of having to type in the same things over and over again. This definitely helps you to avoid code repetition. Thank you for watching, and I will see you in the next video.